All right, my friends, let's see if you figured it out. For part A, it's kind of funny. Some people have a really easy time with part A, super duper struggle with part B. It's almost like if you think part A is hard, then when we go through it, you think part B is easy. Anyway, so let's go through it. They said the first term's 28, so that's good, and it would be nice if we could figure out the second term. So let's make sure that everybody knows how to interpret this. And there's an easy way and a not so easy way. So if you did it the easy way, but you couldn't figure out part B, then pay attention to this, which is the not so easy way. So for this rule, what you could do is you could just slow down and say, hey, like, dear function rule, what would you say if k was equal to 1? And let's just kind of follow our nose here. If k was a 1, then replace both k's with 1s, and it would say a sub 1 plus 1 is 2 would equal a sub 1 minus 4. And so now let's think about that. It's saying your second term is just your first term take away 4. And so, well, your first term was 28, so this would equal 28 minus 4, and so that would be 24. So now we know the second term is 24. So how could we get the third term? Well, you could just go back to your original function rule and ask it, hey, dear function rule, what would you say if k was 2? And it would tell you if k was a 2, you'd have a sub 3, yep, equals a sub 2 minus 4. And just in the nick of time, you had just figured out a sub 2 is 24. And so you'd end up with 20. And you can keep at it, but sooner or later, you'd notice that the terms have a pattern of their own, right? So you started at 28, then you drop down to 24, and then you drop down to 20. And so every time we're just going to keep subtracting 4. And my goodness, isn't this what it was saying all along? It's if you have a term in your list, you take 4 away and you get the next term. And so anyway, so at some point, a lot of us would drop this extra work and just say, oh, I figured out the pattern. A sub 4 is 16, and a sub 5 would be 12. And there you go. I figured out the pattern. So let's list the terms using this notation. So your first term was 28, then you got 24, then 20, then 16, and then 12. And this sucker goes on in that fashion forever, but we were just asked for the first 5 terms. So hopefully that makes sense in the show lots of work way and the not show lots of work way. Okay. Now let's take a look at part B. Part B is kind of great because it tells you what the first 2 terms were, right? So 2 down, 3 to go. But then it has a more complicated function rule. But that's why they had to give you the first 2 initial values in order to get anywhere with it. So you could do the same thing with this one. And this is where this showing a little more work would make some sense. So let's see, let's ask this function rule. Dear function rule, what would you say if k was 1? It would say a sub 3 is equal to a sub 2 plus 2 times a sub 1. And that would equal, well, a sub 2 was given as 6 plus 2, and I can substitute 2 in for a sub 1 because that was given as well. So we just got the third term to be 10. And then I do think that for this problem, this method that I'm using actually shines. I would just keep using it the whole time. So if k was 2, go back to this function rule and just let k be a 2 and simplify as you go. It would say a sub 4 is equal to a sub 3 plus 2 times a sub 2. And then luckily, we just figured out that a sub 3 was 10, so you could replace a sub 3 with 10. A sub 2 is given as 6, and it looks like I'm getting 22 there. One more round and we'll be done. So let k equal 3, and this thing will spit out what a sub 5 should have been. So it'll tell you a sub 5 would be a sub 4 plus 2 times a sub 3. All right, a sub 4 we just figured out was 22, and we're going to do 2 times a sub 3, which was 10. So let's see, what is that, 42? There we go. All right, my friends. So from here, we would just list the terms. So the first term was 2, then we got 6, and then 10, and then 22, and then 42, and the sequence would continue in that manner forever. There you go. I just realized that I've been using these brackets, and I know that some people suffer from being able to write these brackets that I'm using. So let's give a little tutorial on how to do them, just in case you struggle with it, because I will expect you to be able to draw nice brackets. So let's make sure that you're good at brackets. Okay, so for the open bracket, that's the one I've been drawing like this. So if you've been struggling, I apologize. So let's fix you right up. So the top of the bracket is an S, if that makes sense. And then, except the bottom of the S is a little flatter, but it's basically an S. And then the bottom of the bracket is like a lazy number 2. So hopefully that'll help you a little bit. So practice a couple times. It becomes muscle memory at some point, but at first you might need to really think about it. So an S and then a lazy 2. S, lazy 2. S, lazy 2. And then the closed bracket, that's this one. That one is a lazy 2 and then an S. A lazy 2 and then an S. Lazy 2, S. There you go. Get those brackets down. There you go. All right, my friends. Next thing. Okay. Let's give you a little practice. So let's see, for example, 5. If I asked you to write a function rule for the sequence, and when I say a function rule, I mean the extrinsic kind. So here, I'll get you started. It's where you say a sub n equals, and you give the function rule that would, if you plugged a 1 in, you get the 1 out. If you plug a 2 in, you get the 5 out. If you plug a 3 in, you get the 9 out. And then you get to figure out how to make it stop at 49. Anyway, so see if you can figure that out. And then for part B, we're going to transition into series. And the only difference between a sequence and a series is a sequence is just a list with commas in between the numbers generated. And a series adds the results together. So see how the numbers are exactly the same, but in the series, you would add all the numbers together as opposed to just listing them. There you go. Now you know the difference between a sequence and a series. And otherwise, I'm just going to butt out and let you figure out as much as you can. And then in the next video, I'll just kind of go through it and make sure that everything's making sense for you.